All right, so today's Tuesday, May 12th, 13th, May 13th, something like that. Okay, but today we have to get ready for the test tomorrow, our last test. Okay, nothing really new today. We just need to make sure that we know how to do all of the math for pH, POH, calculating molarity of acids and bases in a titration like the lab. The lab is going to be due on Thursday. I talked a little bit about it yesterday. I also talked about the acid-base nature of salts. So if you were not here yesterday, you need to watch that video and just be able to identify whether or not a salt is going to be acidic, basic, or neutral. That was pretty much the new material yesterday. So if we look at this, I want you just to get real comfortable with this. Really, you should not need this, okay? There's just basic equations for pH and POH. We know pH plus POH always equals what?
14.
14. H plus times OH minus always equals what? When you multiply the H plus concentration times the OH minus concentration, you're always going to get 10 to the negative 14. Okay? And then pH is just defined as the negative log of H3O plus. POH is the negative log of OH minus. Okay? But if we have these, so we did this one super fast yesterday. But if I have the POH is 4.75. Right off the bat, what can I say the pH is going to be? 14 minus 4.75, which is going to be 9.25. Okay? That should be a real simple something that we just know pH plus POH always equals 14. Okay? So now, when you look at this, okay, I know what the POH is. I need to go to the OH minus. So what does it say across that top arrow, the arrow that's pointing to the OH minus? How do I find the OH minus from the POH?
10 to the power of the negative.
Okay, 10 to the negative POH, right? So you're just going to say my OH minus is equal to 10 to the negative POH, which means it's going to be 10 to the negative 4.75. which turned out to be 1.77 or 1.8 times 10 to the minus 5. And that's the concentration. It's always going to be in molarity. Does everybody see on that reference chart on how to find that? Does everybody see what I'm talking about on how to do all that? Yeah, you can get it out. Okay? So now there are two ways to go from here. Okay? Now, to me, the easiest, we already subtracted, we know this. So if I know the pH, how do I find the H3O plus? If I know the pH here, how do I find the H plus? 10 to the minus pH. So I can simply say that H3O plus is going to equal 10 to the negative pH, which is going to equal 10 to the negative 9.25, which turns out to be 5.6 times 10 to the minus 10th molar. Now, we could have just as easily, or, not and, or. This, to me, this is the easiest way. But once you know the OH minus, how else could I find the H3O plus? What do we know the relationship is between OH minus and H3O plus? Multiply, they equal 10 to the minus 14. So we also know that Kw, the water constant, is 1 times 10 to the minus 14 is equal to H3O plus times OH minus. Right? So if I know OH minus, I just divide that in and I get H3O plus. So this is just a different way, whatever floats your boat, H3O plus could be 1 times 10 to the minus 14 divided by 1.8 times 10 to the minus 5, and that's still gonna get you the 5.6 times 10 to the minus 10 mole. Now I'm rounding off, you might not get exactly, you might get, 5.5 instead of 5.6 depending on rounding. Okay, now the thing is that it's the circle of life right here. It's just, it doesn't matter which way you go, right or left. You can get from here, you can go to here, you can go this way, or you can go this way. It doesn't matter, you're still gonna get from here to there. Okay? So there's different ways in which you can do the exact same thing. They're all 100% right. So let's just do one more of this, and then I'm gonna kinda let you kinda work, and then just kinda see. So if I hear, what are the H3O plus, OH minus in a solution with pH of 2.25? Well, how's this one gonna be different than the one above it?
Let's just get it to
You just do the pH first, right? I don't even think I need to, I'll let you guys do that, okay? So now, number 3. Let's look at number 3. What are the H3O plus, OH minus, pH, POH if I have this? Now first off, I look at that. Is that an acid or a base?
base.
How do we know it's a base? OH, is it a strong base or a weak base? Do we guess? Okay, what do I look at on the chart?
The left side.
I want a lowercase b, lithium, sodium, potassium, rubidium, cesium, strontium, barium.
Very strong.
Huh? Strong base. When you put a hydroxide with it, so this is one of those. Therefore, this is a strong base. That means it's going to ionize 100%. Okay? Which means, what's my OH minus concentration going to be? But what's the actual number going to be for my OH minus concentration? 0.000635. Okay? Because when this goes in, for every one of these, I'm going to get a lithium and I'm going to get a hydroxide. They're going to break apart into 2. Okay? But this is all I'm concerned about is the OH. So, whatever this is, that's what that's going to be. So my OH minus, this is my starting point, is 0.123635 molar. Okay? Now, I mean, there's just you can go any direction now off the chart that you want to go, because we need to find everything. What's the easiest thing to find from here? If I know the OH minus, okay? I can find the H3O plus. I can find the POH. To me, finding the POH is easier. Okay? But again, it doesn't matter which way you go. How could I find the POH? That's a lousy O. POH is going to simply equal the negative log. So this is already on your calculator. You just put this in, 635. And the POH, somebody do it. What's that come out to be? Let's get 2 decimal places on the POH. If I'm remembering correctly, this is 3 sig figs. When you take the log, you're supposed to have 3 decimal places in the number you take the log of. But we're only going to go 2.
3.197.
So 3.20. Okay? So now, once I have the POH, what's probably the next easiest thing to find? The pH, which is simply going to be 14 minus 3.20, which is going to equal 10.80. That was easy. And then, how can I find my H3O plus from that?
What do you use it?
Well, I could use this.
Because that's the given.
That's a given. That's probably a good idea because you've been rounding. Okay, but either way, you're going to get 100% credit on a test. Okay, so what are my 2 ways to find H3O plus? What are you saying to do?
OH minus times H2O plus equals.
So we'll just shortcut it. H3O plus is gonna end up equaling what?
10 to the negative, wait.
I know, but what are we gonna put it here? What over what?
1 times negative 10 to the negative 14 over
Point, what, 30635. Okay, that's one way to find it. And you could have done that first. You could have done that right here. So again, there's just, once you know one, you can go to all of them, and there's a variety of different ways you can get there. What did that come out to? Anybody helping me on the calculator?
You said,
Y'all need to be practicing putting this in your calculator. 1.57 times 10 to the minus 11th molar. Okay? So that's one way. What, using pH going this way, what could we have done?
10 to the power of negative 2.
Or H3O plus can equal 10 to the negative 10.8, which should be the same number. Somebody plug it in and tell me we get the same number?
1.58.
1.58 times 10 to the minus 11. Both of those 100% right answers. Okay? So there's a variety of different ways that we can do this. Are we good? Does anybody have any questions on where numbers are coming from, or how do you know what to do? Everything's pretty much, everything you need is right here on this. Okay? All right, let's do one more then, as far as the titrations. And then on your study guide that I gave to you, you have more practice. So on the back side here, I want to look at number 6 first off. Because what's BaOH2 going to dissociate into? Ba2 plus what? 2 OH minuses. So if I have 0.075 molar, 0 molar of that, what's my OH minus concentration going to be?
Multiply by 0.
Yes, you multiply it by 2. Because for every 1 BaOH that you put in, you're going to get 2 OH minuses. Okay? So you just multiply that by 2 and it's going to come out to 0.150. So now everything else is the same. Now you know your OH minus, now you do it just like the previous problem. You know your OH minus, you can find your POH, you can find your pH, you can find your H3O plus. You just need to know with strontium and barium hydroxide, these are going to be the only two. Strontium and barium hydroxide, since it's OH2, you're going to get 2 hydroxides for every one you put in. So you have to double for the hydroxide ion concentration. Okay? Good on that? So now, all of a sudden, we have a chemical reaction. Now, all this other stuff, everything up to leading up to this, has just been what's the pH of this one solution. Now, all of a sudden, we have a neutralization reaction. Okay? How many milliliters of this NaOH needed to neutralize 200 milliliters of this acid? So what equation do we have to use for that? What simple equation? How did we do it for the lab? Concentrate, not the concentration's equal. Moles are equal, but how do you get moles from concentration? It's always going to be
volume of the book.
MAVA is equal to MBVB. Okay? Whenever you have a neutralization reaction, that's going to be, this is what you're going to do. This is what we have to do for the lab calculations.
You number 5.
I'm doing this one right now.
I know.
Okay, I'm right in the middle of this one right now.
I'm doing that.
Okay? So, what's the question asked?
How many milliliters?
Of
Anyway,
NaOH, which is the acid or the base?
the base.
The base. So which one of the 4 variables that I have there, what one am I looking for?
Left one.
The milliliters of volume of the base. Yeah, it's a BB.
Okay, the milliliters, okay, liters is a molarity or a volume.
Volume.
This is the volume. How many milliliters of NaOH? So which one am I looking for?
BB.
VV. So that's the one I'm looking for.
Does it matter?
Not really, but I mean, you just need to know when you're plugging in the variables, which one is which. Know what the letters mean, don't just plug numbers. So, what is the 0.150? That's the molarity of the base. Okay, 200 milliliters of 0.25 molar HNO3. Now we recognize that HNO3 is an acid. Those of you that were here yesterday, would it matter if it's a strong acid or a weak acid? Does it take more or less base to neutralize a weak acid than it does a strong acid?
Takes more than neutralization.
It's not.
Those of you that were here yesterday,
It doesn't just get
does it take more or less? Takes the same. It takes the same. You watch the video and it'll explain why. Okay? Why
Why you laughing so hard?
Why are we laughing at watch the video? Because I know you guys are gonna have, I mean, if you don't want to, that's fine, just miss the problem. Okay?
Luke's got a shout out for the video.
Lucas did get a shout out in the video. Yeah.
You should watch it.
Good. Okay, so we just plug in now. So the molarity of the acid is what? 0.250 molar. Now the good thing about this is because it is a ratio, I don't have to convert the volumes to liters, even though that's moles per liter. Because if I divide this one by 1,000 and I divide this one by 1,000, the thousands are going to cancel out. So you can keep it in milliliters. So I can just say 200 milliliters. And what's that decimal point mean?
This is exact.
3 sig figs, it's exact, is equal to the molarity of the base, which is 0.150 molar, times the volume of the base. So how do you solve for VB?
Divide the left side by 1.5. By 1.5.
So the volume of the base is going to be 5/3. So it's going to be 1,000 divided by 3 is 343.
Or, yeah, just the BB.
Okay, so that means that if I have 200 milliliters of 0.25 molar HNO3, and I begin titrating that with NaOH, and I have my phenolphthalein in there, it's colorless in the acid, it's going to take 333 milliliters of the NaOH to get to, finally to change colors. Okay? To neutralize it, to where the moles of H plus equal the moles of OH minus, to where I completely balanced it out. Notice that the NaOH is less concentrated than the acid. Therefore, it takes more volume to get to the same number of moles. Okay? Now, this is the exact same thing you have to do on your lab. Except we're looking for the molarity of the acid in the lab. You're looking for the molarity of the vinegar. Again, those of you, by the way, those of you that missed last Friday, you missed the lab. I posted yesterday late afternoon an exciting video starring Piper and Holly, okay? And we videoed them doing the lab. So you use their data, just fill in, and then you can do all the calculations and answer the questions. On the video yesterday, I did answer the question on the total net ionic equation. So you can, at the very end of that, you can see that as well as far as how to do that, which is a question for that lab. The one thing that we don't have, and I'm actually going to change things, the lab's going to be due on Friday now.
It's like you gotta be doing.
No, because
Please.
no.
I need that.
That's so little content.
I'm sorry, but you guys got to take the test on Monday.
Do what?
Yeah, that's fine. Should we do like, untested?
Yeah, should we do the test?
And you
Well, that's fine. I can make it do test day. I'm just not going to give answers.
Yeah, that's fine, that's fine, that's fine.
Yeah. We're not
Wait,
gonna-
you get Yeah.
They don't know the answers to mine.
What about Sunday night? No.
Yeah, but-
What about we scan it? What about we scan it? Yeah, and then we post at Sunday night at 7 p.m.
What's the point of having the answers?
Wait, that's
study
smart.
on trigger.
See, like you scan it, and that's what
Well, it's a study guide. You should be able to do them all. Okay? You have notes, you have the answers to everything already.
It's like 10 hours.
It's like 15 pages.
The lab.
It's just so little content. We're like,
Go. Sunday.
We have three tests this week, and we got like 5 study guides.
Yeah, we got one of these.
Okay, so there's been a change due to whining and complaining.
Yes.
Okay? All right?
We're gonna X out the whole back.
No. Okay?
What a try.
There's a change in that the exam study guide is now going to be due on Sunday at 6. But your lab, listen to me, your lab is going to be due on Friday. Because on Thursday, we need to get class data on the molarity so you can answer questions based upon class data. Okay? So we just have to get class data. So by Thursday, your MAVA times MBVB needs to be done. Now that's literally 3 minutes worth of calculations to do that. Okay? When you do the MAVA equals MBVB calculation, we need to get that done for Thursday. We get class data, and then you can turn the whole thing in on Friday. Okay? All right. So what I want you to do now is on the study guide for tomorrow, let's focus in on the problems on that study guide and make sure that you can do those.
Just points.
This is not points, this is study guide.
Can you explain to me number 6 again?
Number 6, you multiply it by 2. Because we get 2 of this, you multiply by 2.
Okay. So,
You multiply by 2. This, one of these is 0.75, but for every one you get 2, so you multiply by 2.
so easy.
All right? So just look at those, and then I'll answer any questions that you have on those problems, but make sure you know how to do the problems. Now, I will say on this one is just 2 parts. Find the molarity, find MAVA equals MBVB, find the molarity first. Once you have the molarity, then you can do it just like these other problems. Once you know the molarity of the acid, you can find the pH, the pOH, and all that kind of stuff. Okay? So find the molarity first, then you can find the pH. Once you know the molarity. All right? So use the rest of the time, and then I'll answer any questions that you might have. And I will post the answers to both the worksheet and this study guide this evening. Okay?
We get this on the test. He's contemplating.
I am contemplating, and I will not make that decision right now.
Okay?
All right. So, all right. So we can shut the video down.
Well, hit that like, smash that subscribe button.